In the previous class, we saw the development of a dicot embryo, which is a major post-fertilization event. Today we shall study about the development of a monocot embryo. So we are going to study about the development of a monocot embryo. One major difference that we saw in the dicot and monocot embryo is that a dicot embryo has got two cotyledons and a monocot embryo has got one cotyledon. But when we see the process, when we study the process of the development, there are some more differences in the development of dicot embryo and monocot embryo. So let us see how the monocot embryo develops. A zygote is formed, which is diploid, that is 2n. So this is zygote. This is the micropylar end and this is the chalazal end. The zygote is always made in the micropylar end. In a dicot embryo, the zygote divides mitotically. The division is transverse and it forms two cells. So a transverse division takes place, which is mitotic division. Towards the micropyle end is the basal cell. This is basal cell and this is the terminal cell. This is of course the chalazal end. But in a monocot, one more division takes place. One cell out of the two divides twice. So a middle cell is formed. A middle cell will be formed. So this is the middle cell. The basal cell not undergo many changes. The terminal cell gives rise to cotyledon, one cotyledon only. And the basal cell, it will enlarge. The basal cell will enlarge and its function is to absorb the nutrition. So this is the basal cell which is enlarged. Now all the work is done, the division, all type of division is done by the middle portion of the cell, which is known as middle cell. Now this middle cell gives rise to epicotyle, then plumule, radicle, then also the root tip or the root cap. As the embryo develops slowly, the basal cell, which became rounded and its function was to absorb the nutrition, slowly degenerates. These terminal cells give rise to cotyledon and the middle cell divides and forms many types of cells, that is epicotyle, plumule, radicle, root cap. Everything is done by the middle cell. So this is the difference in the development of a dicot embryo and a monocot embryo. In a dicot embryo, you saw the basal cell dividing many times transversely to form the suspensor. Here the suspensor is not formed and if at all it is formed, then it is in very small proportion, which gradually disintegrates. The cotyledon, which is formed by the terminal cell, is single. This is the embryo of a grass. So the cotyledon is very light, papery. So it is known as scutellum. This is also known as scutellum. The scutellum is located at the one side of the embryonal axis. The shoot apex is formed just above the embryonal axis. The shoot apex grows into plumule, and above the plumule, the shoot apex, it has got a covering, a protective sheath, which is known as coleoptile. The lower end of the embryonal axis terminates into radicle and the root cap. The radicle and the root cap are also covered by a protective sheath, which is known as coleorhiza. Now we take the diagram of a maize seed. Maize is a monocot seed. The outer covering is epidermis. We can write it as pericarp and the seed coat. So let's write it as pericarp plus seed coat. The next layer is a layer of protein sheath. This is a proteinaceous layer. So we call it as allurone. Allurone. I'll write it here. This is allurone. This is a proteinaceous layer. The next is the endosperm. Endosperm. This is the embryonal axis. Embryonal axis. This is the coleoptile. This is the coleoptile. This is the plumule. Just below the plumule is the radicle. And a protective covering is there, which covers the radicle and the root tip, which is known as coleorhiza. Coleorhiza. The endosperm portion is quite big, and whole of the endosperm is utilized during the development of the embryo. Seen the development of a dicot embryo and the development of monocot embryo. The major differences what we can see is that a dicot embryo has got two cotyledons, a monocot embryo has one cotyledon. There is no protective covering on the plumule in a dicot embryo. That means there is no coleoptile. But in a monocot embryo, coleoptile is present. In a dicot embryo, the radicle does not have any protective covering, that is, coleorhiza is not present in a dicot embryo. But in a monocot embryo, coleorhiza is present.